Hello,
Hey, how's it going?
how are you?
Good.
Let us begin. Um, on Wednesday, I showed you how to get confidence interval when the sample size is large, when n is greater than 30. If you can remember, this here, you can see n is greater than or equal to 30, and standard deviation is known. Now, for this type, we're about to do, and I also show you how to calculate the minimum sample size. Today, we're looking for a different approach whereby if the sample size is small and we don't know the value of the population standard deviation, say standard deviation is unknown, we use the methods we called that involved using a T distribution table. Give me 1 minute, let me open that table that I told you about. Excuse me, I gotta open this. File Explorer. Oh, excuse me. Yeah, that's what I need. Just 1 minute, let me open this table. Get statistical table. Okay. I think it's a little bit okay. Yep, this is the table right here. So the one we did on Wednesday and I think on Monday, I was using this table, which is table 5, I believe. I was using table 5, which is this one here. Let me share it. Table 5, this one. Now, for the one I'm about to do now, we're going to use this table called student T distribution. So that we use it when the sample size is small and we don't know the value of the population standard deviation. Let me close this part. Okay. Now I can share this. Okay. You can see this. Good. Now, so in that case, we use student T distributions. Why do we call it student T distribution? It has an interesting history. In the long time ago, in those days, the people that work for companies are not allowed to publish anything that's related to that company or because of the competition we have there. So William W.S. Gazette, he worked for a brewery, and while doing that, working for the brewery, he was doing research, and he found that about this table that it can be used to do a lot of calculations that are very useful, and he wanted to publish it because they're not allowed to publish their findings because of the competition they have with other breweries. He published it with the name student. He used the name student to publish it. That's what we call it, student T distribution. Now, again, like I say, it is used when only we don't know the population standard deviation and when the sample size is small. So let me show you how to use this table. This table is based on the sample size and also on what we call degree of freedom. We call what we call degrees of freedom, DF. DF, which is degrees of freedom, which we can find from the table. Now, the DF, degree of freedom, is for T distribution is the way we get it is DF equals n minus 1, where n is the sample size, and then, of course, DF is the represent the degree of freedom. So let me show you how to use the table first. The first example on how to use this table, maybe you can do up to 2 examples. It says, Martel says, find the T alpha over 2, that is, it means find the critical value, alpha over 2 because it is left side and right side, so 2 sides. So find the T alpha over 2 value for the corresponding confidence levels. Now, so first of all, it says part A says 95% confidence level with n equals to 22. Part B says 99% confidence level with n equals to 10. And C said 90% confidence level with n equals 14. Now, let me show you how the table looks like first. Then you can see how you can understand it better then. Let me show you different parts of the table. That's the best way of saying it, per se. Now, make it a little bit bigger. Now you can see for the table, we have the different, the A prime mean only one side. A double prime means left side and right side. And of course, you can see the DF, which is the degrees of freedom, all the way to the last one, 120, and then the infinity. Now, 1 minute, I want to move this a little bit to the left, okay? Now, okay, since I can move it, let me move this one there, okay? Now, you can see from this table, we'll be using A double prime because we'll be having left side and right side. So now this first part, 0.25, that means you are 75% confidence. Your chance of being wrong is 25%. 0.2 means 20%. And that means for the 80% confidence level, that means your chance of being wrong is 20%. This is for 85%. This is for 90% confidence level. This is 0.1. So your chance of being wrong is 10%. 0.05 is 5% for 95% confidence level, which means your chance of being wrong is 5%. So on and so forth. See? Now, and of course, DF. With that, we are ready to do some work. The first one says, I'm gonna do this again. It says A. It says 95% confidence. 95% confidence. Here, n is 22. So n is 22. N equals 22. So that degree of freedom, df, becomes n minus 1, because it says n minus 1. N minus 1, which is 22 minus 1, okay? And that gives us 21. So that's what we look for in the table. So that your alpha is a 95% confidence. That means your chance for being wrong is 5%. So the alpha will be alpha is equals 0.05. So that we can now get the critical value T alpha over 2. So our T alpha over 2 will become let me see, yeah, equals, then we look at the table, okay, excuse me, the alpha over 2 now becomes this figure. So we have our degree of freedom as 21 and alpha is 0.05. We can now go to the table and look for it, the table of the T distribution table. Now, alpha 0.05 for 21 degrees of C, 0.05. Remember, use this prime because it shows left and right. Then the alpha 0.05 is right here. Then you go all the way to 21 degrees of freedom, which is right here. You can see it from here. So that is for alpha 0.05 with 21 degrees of freedom. So the answer becomes 2.080. Let me write it down, then we can put it on paper. 2.080. So we can now go back there and put our critical value as 2.080. Any questions on this? Any question?
No, no question.
B. Let's do B, then we can now go straight to calculating the confidence interval. Now remember, we use this method if and only if the sample size is small and we don't know the value of the standard population standard deviation. And I'll give you the various conditions as soon in a few minutes. The other one, it says part B is a 99% confidence level and N is 10. So here N is 10. So that the degree of freedom, DF, equals N minus 1, which is 10 minus 1. That gives us 9. And in this case, our alpha, because it says 99% confidence level, so our chance of being wrong will be 1%. So our alpha will be 0.01. That's 1%. So that the T alpha over 2 or T alpha over 2 will now become, we go to the table and look for under 9 degrees of freedom and under alpha 1%. So we go there. We have here 0.01 is right here. So go under 9 degrees of freedom. So 0.01, you go to 9. Okay, 9 should be here. So you can see 0.01 to 9 degrees of freedom, 3.250. 3.250. That gives us 3.250. So this is how to use the table. We use it to get the critical value, and then we plug it into our formulas to get the confidence interval. The formulas are the same, except that now we're using samples. We're going to be using sample standard deviation. And also, just a little small, slight tweaking of the formula. Other than that, we still have to find the error margin, and the formula for error is still the same. So let us try. Let me give you these formulas here. So I'm going to take you to the workbook, so you can write the formula down. The error margin is also obtained using this formula. Instead of Z, this time we'll be writing T error. Error will now becomes T alpha over 2 error margin E equals T alpha over 2 will be here. Excuse me. T alpha over 2. Okay, T. Then alpha over 2. Alpha over 2. Alpha is, we can find from here. Okay, over 2, which I just showed you how to get it, times the standard deviation over root n times standard deviation. This time we use sample standard deviation S over square root of the sample size, which is square root of n. Okay. So to get our error. So once we get our critical value, we get our error using this formula. Okay. Taking you back to the main workbook. Okay. Now, and once you have it, we can then get our confidence interval by doing the same thing, x bar minus error less than the mean divided by s bar plus error. So you're gonna be confidence interval will now become we give it by x bar minus error. So less than the mean mu which is what we are trying to estimate. Less than S bar plus error. S bar plus error. And that will give us our confidence interval. Okay. So I'm gonna copy this. Oh, excuse me, plus error. I need to set input plus error here. Plus, excuse me, plus error. So on the left side, you subtract the error, just like we did on the other example for when the sample size is large and we know the value of the population standard deviation. So the confidence interval is given by this formula, S bar minus error. Once you get the error margin, you are almost done. In fact, you are done. They can just put the confidence formula and then get it and then make your conclusion. So let us do an example here. So first of all, find the critical value, find the error margin, then plug it in. So let us do this example. It says here, a sample of 6 college wrestlers has an average weight of 276 pounds with a standard deviation of 12 pounds. Find the 90% confidence interval for the true mean weight of all wrestlers. And find the coach. If the coach claimed that the average weight of the wrestlers on the team, it was 310, would that claim be believable? Okay. Before I proceed, I want to show you that, tell you that your project will be based on calculating confidence interval. I'll give you a raw data, and then you use that to estimate the mean for the population using that raw data by applying the confidence interval method. So I will probably by next week, I will by this weekend actually, I will have it uploaded for you so you can begin work on it. Excuse me. Now, one thing about this example is that the sample size is small, 6. Now, and for this sample of 6, they say that the standard deviation for this sample of 6 is 12 pounds. How about the population standard deviation? We don't know. So this qualifies this example for this approach because the sample size is small and we don't know the value of the population standard deviation. It means that we'll be using the T distribution table for this. So our sample size n equals 6. Okay, and n is 6. And then we have that degree of freedom equal alpha. Well, degree of freedom will be n minus 1, which is 6 minus 1 plus 5. Okay. And so alpha, it says find the 90% confidence interval. So in that case, our alpha will be, the chance of being wrong is 10%. Alpha will be 0.10, 10%. So that we can now find the critical value of T alpha over 2. T alpha over 2, have alpha over 2 equals, now we go to the table and then get our T alpha over 2 from the table. So let's get to the table. We have it as here under 5 and under 0.1, which is 10%. Just a bit wrong, so you can have it right here. If you play this, you can see the 5 here and 0.1, which is 10.10. So 2.015. 2.015. So I copied it out, and so I'm gonna put it over there. Okay. 2.015. 15. Now the sample mean X bar, you say for this sample of 6 wrestlers, the sample mean is 276. So that character for sample mean, I have to get it from the other workbook. So I go take you to that workbook to get the sample mean. Oh, excuse me. 1 minute. Let me get. It says 276. Let me write 276 down because of. Okay, 276. Now we have to get it from the character there, so we can put it back here. Sample mean X bar. Okay, equals 276. Okay, then copy this and then put it there. So this is 276. Okay. Now, sample standard deviation S equals make it a little bit bigger. Okay, S 16 we're using color 16. So sample standard deviation is, according to this paper, is 12 pounds. Now we're ready to plug all this into this formula here. Okay, ET alpha 2 times standard deviation over root n. So you're gonna be, let me write it down, then I'll go and put it in there so you can see it. Have the error equals T alpha over 2, which is 2.015 times standard deviation of 12 over root n, which is square root of 6. Okay, so that will help us get the error. So I'll take you there and put n. So the error margin equals T alpha over 2. Okay, T alpha over 2, and then we can find alpha from here over 2 times, okay, square of standard deviation S over the square root of n, okay, and which means we plug it in, we're going to have T alpha over 2 is 2.215, okay, times standard deviation of 12 over the square root of n. Our n, the sample size is 6. So we can get this from the calculator. Now, let's get it from the calculator. We go to, and then we put the answer here. Okay. Now the calculator is right here, decimals. So we have 2.015 times we have standard deviation, okay, which is 12 divided by square root of 6. Okay, that gives us 10.018. Excuse me, let me check something here. 10.018 minutes. Okay, I have I put 2.015, 9.87 I got. So give us 9.87. Of course, it's 9.8714 4843663, but I stop at second decimal place. 9.87. So give us 9.87. I will put it right here. 9.87. So that becomes our error margin. Okay. Error margin is that. I'm gonna take you to the main workbook and put this work that we just did in. Okay, with this, we have our error margin as 9.87. We can, with this, we can now find the confidence interval. So the 90% confidence interval will be given by that same formula, since we have the error margin. This. So it will be given by this formula. The 90%, okay, confidence interval will be given by S bar minus error, less than mean, less than S bar plus error. So on the left side, you subtract the error margin. On the right side, you add the error margin. That will give you the required 90% confidence level. So that we have X bar, which is sample mean of 276 minus the error of 9.87. Okay, less than the mean. Okay, let me see. Less than the mean. Okay, and less than. Okay, let me see. And less than Okay. S bar plus L 276 plus 9.87. So when you simplify it, and 276 minus 9.87, let's get a 276. From the calculator, we can have 276 minus 9.87. That gives us 266.13. Yes, 266. 266.13 pounds less than the mean. Okay, and less than, you add it on this side. So we go there and put it back. I change this to plus 285.87. 285.87 pounds. 285.87 pounds. So this is, remember, this is part A of the part A. Okay. Now, so this is the confidence interval between 266.13 pounds to 285.87 pounds. So let's conclude. Conclusion. Okay. Conclusion. We can say with 90% confidence. We can make it this so that it doesn't interfere. So we can say with 90% confidence that, now this question is about the weight of, average weight of wrestlers. So you can say that the average weight of wrestlers, that the average weight, don't forget to put the average. If you don't put the average in your conclusion, then your conclusion will be wrong. Remember, because you are trying to estimate the mean, which is the average. So it is very, very important that you include it in your conclusion. When I put the project, I will show you how I will put the apportion your grades on the project. So the average weight of the wrestlers is between 266.13 pounds to 285.87 pounds. Any question on this? Any question on this?
No questions.
So let's look at part B then. Part B says, so suppose if a coach claimed that the restaurants, the average weight of the wrestlers on the team was 310, would that claim be believable? Now, we know that the average weight is between 266.13 pounds to 285. Now, this coach is claiming that the average weight of wrestler in the team is equals 310 pounds. So that claim is not believable. So the answer is no, because weight of 310 falls outside the range, outside the interval. It doesn't fall within these two intervals of 266.13 pounds to 285.87 pounds. So this is how we do it when the sample size is small. Sometimes, like the one we do in your project, you'll be given a list, like one we did last Wednesday, where you have a list like this, and you're asked to find the confidence interval. In that case, I'll give you a raw data. You will calculate the population samples, the population's mean and sample mean and sample standard deviation by yourself, and then use it to calculate. I'll give you the confidence level. Then you use it to calculate your confidence interval, and then make your conclusion. Then write, okay, you're gonna have an introduction, what you are planning to do in this project, then the actual work itself, and you find the conclusion. If you like, you can use Excel to do find the sample mean and sample standard deviation. And then, but you have to mention that you use Excel, and you have to attach the spreadsheet so I can see where you do your calculations, and then you can even paste it in the work. So it's gonna have a cover page, and then an introduction, the actual work you're finding, that is the confidence interval, then your conclusion. Now, so in that case, remember, even though that I give you the sample size and this, you still have to find the sample mean. Now, let me show you some conditions that we use to determine whether you are going to use this second method or the third method. The second method, already you know that if the sample size is small and we don't know the population standard deviation, we use the table. But there's some exception to that. Now, when the standard deviation is known, then you can use critical value. Because the alpha over 2 values can be used no matter what the sample size is, as long as the variable is normally distributed and the sample size is large. For the matter, if you are told that the population so long as you have this population standard deviation, and you are told that the data set follows a normal distribution, you can use the Z table. Even if the sample size is 10, but you know that you are given the population standard deviation, and you were told that the sample the data is a standard normal, it's normal. That said, it's not assumed to be normal. Now, when the standard deviation is unknown and the sample size is large enough, the sample standard deviation can be used in the formula, and you can still use the Z table. Just this is the one that applies to your project when the sample size will be large enough, and you can still use them. Now, when the standard deviation is unknown and the sample size is less than 30, then in that case we have to use the T distribution table. Any question on this? Any question?
No.
Now, since there's no question, then if you look at this one, it says find it says the following data sets represent the sample of number of home fires started by candles in the past several years. see, home fire started by candles in the past several years. This one is 5, okay, 5,000 home fires. This one is okay, and so on and so forth. You know, it says to the okay, good. You see, find the 99% confidence interval for the mean number of home fires started by candle each year. Now, what you do here is to you are not given the sample standard deviation, and you are not given the population mean or the sample mean. So you have to calculate them by yourself, and then use it to find the confidence interval. So let's also this be our last example today. So solution, you have the chance, you can try number 12 by yourself as a practice. Solution. Okay. Here, how many, the sample size is 1, 2, 3, 4, 5, 6, 7. So n equals 7. Correct this. N equals 7. Okay. So that degree of freedom equals 7 minus 1, which is 6. And our alpha is a 99% confidence level. So our alpha will be 1%. Your chance of being wrong will be 1%. Okay. So our alpha, let me put it right there. I think I can put it, okay. But I have to go all the way there. So we have alpha will be equals 1%, that is 0.01. So that the degree of the critical value T alpha over 2, T alpha over 2, alpha over 2 will be, now we can get that from the table of T distribution. I have under C degree of freedom because the degree of freedom is 6. Alpha is 1%. This is 1% right here. So we go under 6 degree of freedom. This is 6 right here. So from here all the way to 6. You can see it from here. Okay. 3.707. Okay, 3.707. Okay, 3.707. So let us find the sample mean and sample standard. That's the X bar. Since we don't have it here, we have to put it in Excel, make it faster for us. So the X bar will take you to Excel where we can put all this information. I have it on my book, so I'm gonna just type it in, and we can get our sample mean and sample standard deviation from there. So we have this here, these numbers. We have 59, 54, 60. Okay, we got 5900. So 6090 home fire started by candles. 6310 home fire started by candle, and 7160, then 8440, and then I have 9930. So you have this is sorry 1, 2, 3, 4, 5, 6, 7. So we have our sample mean, and then we need to get our sample standard deviation. Sample standard deviation, ST. Okay. Now, with this, you can figure this out. The sample mean, like I showed you at the beginning of this semester, how to calculate the mean using Excel. I put the equal sign to keep it Excel in a ready mode. Then you type average. Okay, and double click here. Highlight this. Okay. Sample mean of 7041.43 if you round it up. For standard deviation, sample standard deviation is STDEV. See, STDEV.S is for sample. Okay, then have it here. I'll give you 1610.272. So let me get this down. I got sample mean X bar is 70. X bar is 7041.43. Okay. Sample standard deviation is this one here. 1610.27. Okay. 27. So you can go down to our work and then put this information. The sample mean, I can, we don't have the character here, so I'm going to get the character from the other workbook. Sample mean will be X bar, X bar, X bar. Okay, it was 7041.43. Okay, and the standard deviation, sample standard deviation S, we have at, from the Excel, we have at 1610.27. So I can just put the put of them here. Okay, and then we can find our error margin. Okay, right. So sample mean and sample standard deviation are here. See, so the error margin, we use the same formula we used to get it, which is this one here. So TF over 2 times standard deviation over square root of n. We write it down, and then we can now put it in to get our error, and then our confidence level. So T error is equal to TF over 2, which is we got as 3.707. 3.707 times standard deviation of 1610.27. 10.27 over square root of n, that means square root of 7. Square root of 7. So let us put this in and then get the calculation done using the decimal. So error E equals some T alpha over 2, which is 3.707 times the standard deviation of 1610.27 over the square root of 7. Square root of 7 is right here. Okay. And that gives us equals, let's get it out from the calculator. So you have it as 3.707. Okay. 3.707 times, okay, we have a standard deviation of 1610.27 over the square root of 7. I can close this out. Have 2256.17. That 2256.56.17. So we got our error as 2256.17. So we can share it here. So the error, oh, excuse me, I will have it over there. So we have 2256.17. So that is our error margin that we have. So I'm going to put it there in our main workbook. And we can get our confidence interval from there. So with this error margin, we have our confidence interval. So the 99% confidence interval will become, the formula again is S bar minus error. Since I have it here, I can just copy the make it faster. Just change the numbers so that the 95%, the 99%, 99% percent confidence that is S bar minus error less than mean, less than S bar plus error. So in that case, our S bar is sample means is 70.1.43. 70 41.43 minus error margin. Error margin is 56.17. Okay. Now then repeat the same process here. At 7041.43 plus 22.6.17. So now with this, we can now find the confidence level interval. So let's go to the calculator and get these answers, then conclude, and that will be it. So we have it at this place, but we have clear, have 70, excuse me, 70, excuse me, 41.43 minus error of 2256.17. We got 4785.26 less than mean. Okay. Then if you add plus here, 929 7.6. Okay. So we can now go to our book and add them in as our answer. So we have 4285.26. Okay, less than the mean. Less than, on this side we have 9297.60. So that our conclusion, okay. Now this is about as I said, the following data represent the sample of the number of home fires started by candle in the past several years. So find the 99% confidence interval for the mean number of home fires started by candle. Okay. Yeah. So we can say with 99% confidence that the average number of home fires started by candles, okay, or we can say with confidence that on average, the between 4,785.26 to 9297.60 home fires are started by candles. So we can stay with 99% confidence that on average, between 785.26 to 9,297.60 home fires are started by candles. I think this is it for today. Like I said, I'm gonna upload your project, and it will based on this topic. You're going to be estimating the average salary of Baltimore City employees. Police, Baltimore City Police for this last past year. Now, if there's any question before I take your attendance so I can leave, any question for me?
No, I don't have
No
one.
question. Okay, let me
No question.
take your names then. We got Aaron is here. Okay, we got Bennett. They have Ania Taylor. Who else? Chambers. Then I didn't see Nichols. Okay. I'll see you guys on Monday. Then have a nice weekend.
You too.
You do the same. Thank you.
Thank you.
Mr. Nick, you still here? You have any question for me?